Hi there, guys. It's Wendy. We are going into week 2 of this. So I hope that you feel like you had an okay amount of work to do. I know that on Monday you had an assignment and then you had 3 days to do your end of unit project before we started probability on Friday. So this week we're going to continue through probability and we're going to end the week with a small quiz just to see how you're doing before we do a review and take a test next week. We actually will finish the unit this week because it's a pretty short one, but I want to just do a small quiz and then give you time to have an actual review that would be very similar to your test, just like we always did in class, and that way you feel ready for your test whenever you have it. All right, so as far as today's note catcher, we're going to go through this and we're going to start with example 1. So I want you to read through this with me, follow along, and hopefully this will help make your work time super quick and easy. So in example 1, it says, consider the spinner shown below that has been divided into 8 equally sized sectors of a circle. So these are all equal in size. The spinner is spun once. In this experiment, we'll let A be the event of it landing on an even. So it's going to go into circle A if it's even. It's going to go into circle B if it's prime. So we want to fill it in. So we're going to start off at thinking about our even numbers, our prime numbers, and then whatever number is both is going to need to go in this overlap because it's even and prime. So we start with number 1, and number 1 is really not considered to be a prime number. So it's not even. So it's going to go way out here. It's not going to be in either category. So then we go to 2. Well, 2 is even and 2 is also prime. So that's going to go in the center here because it's both. And then we go to 3. Well, 3 is prime, but not even. So it goes here. 4 is not prime, but it is even. 5, we're back to prime. And so that's in the primes. It's not even. 6 is even, but not prime. 7 is prime and not even. And 8 is even and not prime. So everything fit into even or prime except the number 1, which is neither, and except 2 was in both of them because it's prime and even. So when we have 2 or more sets, we have either a union or an intersection. So we want to talk about this. So the union of the evens and the primes, you can literally just count all of these. 1, 2, 3, 4, 5, 6, 7. There are 7 of them in the union. And then for the primes, for the intersection, you're looking at just what is in that little intersection, that overlap of the Venn diagram. So let's look at example 2, A and B. So for A, we have A or B, the union. It's either going to be in A or it's going to be in B. Well, that's literally everything inside of this bubble right here. So literally it's all of this, all of this. So if we want to write the set, I'm sorry, I didn't move up. All right, so if we want to write the set of the union, then that would be 2, 3, 4, 5, 6, 7, 8. Basically all the numbers except for 1 because it's not, 1 up there wasn't in either one of them. All right, so then we're going to go to the intersection. Well, if you look back up there, the intersection is just the number 2 because that's where we had an overlap of what was prime and what was even. So then we're going to go into example 3. So looking at example 2 that we just did, why is the equation the number of A or B equal to the number of A plus the number of B generally not true? And what would we have to do to make it true? All right, so first of all, if we look at A or B, there were 1, 2, 3, 4, 5, 6, 7. But if I add, so if I say n of A or B, we just calculated that and there were 7 of them, the number of answers in A or B. But if we take the number of answers in A, and we add them to the number of answers in B, well, let's go back up to our picture. So the number of answers in A, 1, 2, 3, 4. The number of answers in B, 1, 2, 3, 4. Okay, so we go back down here, and that's 4 plus 4, which is 8. So those are not equal, right? 7 and 8, they're not equal. So then the question becomes, what do we need to do to take care of the fact that those aren't equal? Well, if you think about it, and you've probably already noticed it, we counted the 2 twice because it's in the overlap. So when we're counting the intersection, the union of A or B, you don't want to recount that number 2. So the way we get around it, we can't do that because, so the problem is they can't be equal because we can't count the overlap twice. We can't double count. You don't want to double count that, right? So we definitely don't want to double count on the intersection. So if we were to add them, if we add the number of A plus the number of B, but then we subtract out that intersection. So we subtract the number that is in the intersection of A intersect B, then we get the number of A union B. And remember, this is the or, and this is the and. So think intersection, it looks like an end in and this is a union or an or statement, and that's in the above description of the 2. So when we see or, we know that's the union, that's everything in there. When we see the and, then we know that's the intersection, so it's just the middle part of that where they overlap. Okay, so hopefully example number 3 makes sense then. We can't assume, it's not going to be true that A or B is necessarily equal to A plus B, because if there is overlap, you're counting it twice. And so we need to subtract it out one time so that we're only counting it once. All right, let's go to the next page. All right, so we're going to go to example 4. So we're talking about a small high school that was surveyed, and surveyed 52 of its seniors about their plans after they graduate. So we have all this data. We have male, female, and total number of students that are going to college, that are not going to college, and then the total numbers of male and females. Okay, so we have this little key right here where we're going to use letters to represent these different categories. So you just need to make sure you're looking at the right category. So we want to know the number of males. So we're going to go over here, and the number of males was a total of 30. Okay. All right. So then we want to know the number of females. Well, the number of females is 22. All right. The number of going to college, because that's C. So going to college, there are 29 total students going to college. All right. And then the number not going to college, because that's what N was. So the total number not going to college was 23. All right. So we want to know the number of males that are going to college, because we want them to be male and going to college. Well, if we look, the number of males going to college is 16. So that's going to be 16. Then we want to know the number of females going to college. They have to be female and they have to be going to college. So that puts us right here at 13. All right. And for the last part of part A, we want to know the number that are females or they're going to college. right? So females or they're going to college. So first of all, the number of females was 22 plus the number going to college was 29. But remember, we have to subtract out what would be in that overlap. And so that's the number that were female and going to college that fit into both categories. So in the Venn diagram, they were in that overlap. And that would be the 13. We don't want to double count them, so we have to subtract out one of those. Okay? So that means that we have 22 plus 29. So is that 51 minus 13? And I don't have a calculator in front of me, so I'll do it over here. 22 plus 29 is 51 minus 13 is 8 and 3. So 38. All right. All right, let's go to part B. So we're going to scooch up just a little and still see our data in the table. So part B says, what is the probability that a person picked at random would be a female who's going to college? All right, so first of all, is it a union or an intersection? Okay, well, it's a female and she's going to college. So this has to be an intersection, right? This has to be an intersection because it's talking about both. So we want the probability of female and college, okay? So what that is that's the number of female and college out of the number of the whole sample, which is the total of everything. So in this case, the number that were overlapping that were females going to college was again 13, and we have that here. And we know that's out of the total number. So the total number of everything and everyone was 52. Okay, so you can leave it as 13 over 52, or you can divide that and round it to 2 decimal places. It actually comes out to be exactly 0.25. All right, so then part C. Part C says, what is the probability that a person picked at random would be a female or someone going to college? Or. So is that a union or an intersection? Remember, and is an intersection because that looks like an N. So a union is the one that is or. So now we're looking for the probability that they're a female or they went to college. So again, this is the number that were female or went to college divided by the number of the total people that we talked about. So we know from the problem up here that the number that were female or went to college was 38. So that's 38. Again, our total number of students was 52. So it's 38 divided by 52. That is an answer in and of itself right there. But you can also convert it to a decimal, and it's 0.73. All right, let's go on to part D. So explain why P of female or college did not equal P of female plus P of college. All right, and we kind of talked about that. They're not equal. They're not equal because in this part, where we're just adding, in this, numbers are counted twice. And that's why, because we did not delete out the set that we repeated. All right, so we don't want them to be counted twice. Okay, and for part E, fill in the general probability law based on D of P of A or B. Well, we kind of did it up here. We have to say that if we want P of A or B, we need to take the probability that A is happening plus the probability that B is happening minus the probability that both are happening. because we've counted that section twice when we added them separately. So we add them, and then we have to subtract out the ones that fit both cases so that we only count that overlap one time. Okay, because this is the part that's been counted twice. All right.